All right, so in example 2, we have an oil slick. It's a circular oil slick, and we're given the density function in terms of the radius from the center of this oil slick. And we're told that the slick extends from 0 to r equals 0 to r equals 5,000 meters, okay? So, and we're asked to find the mass of the oil slick. So this is a little bit, it's a little bit different from the last one, right? So let me just draw what we've got here. We got a circular oil slick, right? It's 5,000 meters in radius, okay? And it's circular now, obviously. This is kind of not so circular, but now we have mass that's varying by the radius. So let's take a slice or a ring of this oil slick. Okay, so if we take a slice of the oil slick that's essentially a ring at some distance from the center. Okay, now imagine that's circular. And let's say we have an R1 and we have an R2 of this ring. Okay, and so we need to. So the way we're going to approach this problem is by taking, these rings and adding them up, and then letting the number of rings go to infinity, right? So that they become smaller and smaller rings. So let's take a look first of all just at the area of one ring, right? Because we're given density now in terms of kilograms per square meter. Okay, so it's varying with the area. So let's take the area of one ring. Let's find out what that is. So, all right, so we basically have two circles, and it's essentially the area of one ring is going to be the area of the outside ring, so pi r2 squared, and then we subtract out the center, right? So that's pi r1 squared. So we can factor out a pi, right? And we end up with pi times r2 squared minus r1 squared, which is the difference of two squares. So I'm going to write that as pi times r1, or say r2 plus r1 times r2 minus r1. Now notice that r2 minus r1 is essentially a delta r. It's a change in r. And if r1 and r2 are close enough, then essentially r1 plus r2 is 2r. So what we're going to end up with is, again, if we take these r values close enough, we're going to end up with 2 pi r delta r, right? Because our r1 plus r2 became 2r, and r2 minus r1 is equal to delta r. Okay, so that gives us the area of one ring. So now we can find by using the density function, we can find the mass of one ring. One ring, right? So we're just going to take this density function, and again, I'll just write it as delta r, times 2 pi r delta r. All right, and then what we need to do to find the total mass is just take all these rings and add them up as the number of rings goes to infinity, right? So we're going to have an integral. So the total mass then is the integral from 0 to 5,000, right? Because we're integrating over the radius now. And the outside radius is 5,000 meters. The density function is 50 over 1 plus r. And then we have times 2 pi r delta r. All right, so let's see. Let's give her some of these constants, clean it up a little bit. So this is going to be equal to, we have 50 times 2 pi, so that's 100 pi. I'm going to pull that out, and then we have the integral from 0 to 5,000. And we have r over 1 plus r. sorry, this should be dr, right? Because our delta r becomes dr. Not sure why I wrote delta r there. All right, so now how do we solve this? I'm actually going to do a substitution. I'm going to say let's let u equal 1 plus r, so then du is equal to dr. Okay, but we have r over r plus 1, but we can actually solve for r. If I just subtract 1 from both sides, I get u minus 1 is equal to r. Okay, so I can then rewrite this integral, and I'm just going to write the indefinite integral down here and solve this kind of on the side. So this r over 1 plus r becomes u minus 1 over u du. Okay, and u divided by u is just 1, right? So the integral of 1 is u, and then I'll have minus 1 over u, which is the natural log. Oops, it shouldn't be. All right, minus the natural log of the absolute value of u. Okay, and then plus c. So that's just the indefinite integral. And now we can go back, now that we know what the antiderivative of that r over 1 plus r is, then I can actually just write this as 100 pi times, okay, and we have to evaluate this. So we're going to have, okay, so u is 1 plus r, so 1 plus r minus the natural log of u, which is again 1 plus r, 1 plus r. And I want to evaluate that from 0 to 5,000. All right, so what do I get when I do that? 100 pi. So I'm going to plug in 5,000. So I'm going to get 1 plus 5,000 minus the natural log of 5,001, right? Because 1 plus 5,000 essentially. And then I'm going to have minus. Now when I plug in 0, so I still have this 1, but r is 1, and then the natural log of 1 plus 0 is also 0. So everything is 0 except for this 1. So it's just going to have a minus 1 there. So I have plus 1 and minus 1. Those will cancel each other out. And then I can evaluate an actual number. So if I put this into my calculator, what I get is that this is approximately equal to 1,573,472 kilograms of oil. All right, so I'll see you in the next video.